Hello everybody, today we are going to talk about arrays. Let's write something like that, int a. Normally, when we define a single variable like that, our compiler allocates memory. In this situation it is 4 bytes, because we have integer variable here. And we can get value from the allocated memory by using identifier, and in our situation identifier is called a. And what if I wanted more than one variable, for example 10 of them? I could do something like that, for example. Int a, b, c, d, e, f, g, h, i, j, and I could just continue that, right? I could do something maybe easier, something like that. Int var1, var2, var3, var4, var5, and just continue that, right? But as you have probably noticed, it takes a lot of time, and all of the values have different identifiers. So I can't use them so easily because I have to memorize all of the names. And what would happen if I wanted not 10 variables, but 100 or even 1000 of variables? Well, it would take too much time to create something like that, and even if we did it, it would be a nightmare using something like that. And again, what will happen if I change amount of variables that I need? You probably can guess. It would be very time consuming. And that's why we have something what is called an array. This is how memory looks like for typical variables and arrays. Here we have the typical variables. As you can see, here we are defining int a and int b. And as you can see, there are many other things stored in memory between variable n and variable b. There might be, but it doesn't need to be like that. But there might be, so we don't know exactly where that variable a or variable b will be put in our memory. We don't know that. We just know that it will be 4 bytes, and it is called, it will be, we can access that variable by using the identifier a, right? Okay, but here we have an array. In order to create an array, we have to write after the identifier of our array, so in our situation this x, the square brackets, and in the square brackets inside we should put the size of our array. And it means right now that for here that we will create an array of 4 elements. As you can see here, an array is a series of elements. Series means that they are next to each other, right? They don't have other things stored in memory between them. They are next to each other and of the same type. It means that we can create arrays only of the same type. So we know that all of the guys here have what? 4 bytes, for example, because the type is integer here right now. So we know that if we jump 4 bytes further, we'll for sure meet an element from that array, right? Okay, now let's go back to our code and let's create an array. So let's create something like that, for example int array, and let's create an array that will be able to store 3 elements, right? So how to create an array? Type next name, and in square we should say how many of them, how many of elements we will have. So size, number of elements, right? Something like that. And right now we know that we created 3 elements that are next to each other. They are the same type. Okay, and how to access, maybe how to get values from that elements, how to assign values to that guys. Well, we can use something like index. In order to do it, we should do something like that. For example, let's assign values there right now. I type array. Maybe let's change it to array, just a bit easier. Array, and in the square bracket, we are telling which element we want to take from here. We'll take element that index is 0. The element with index 0 is the first element. Okay, so I was saying here, for example, 10. Now let's do the same thing to other elements. For example, that way. Something like that. I was saying different values, and I just assigned to all possible elements something, 10, 50, and 256. Because we have 3 elements, right? The size of the array is 3. And as you have probably noticed, we have to count elements from 0, 0, 1, 2. There is no such thing like array 3 right now here. I can't do something like that. I can't assign things here. If I do it, of course, that thing will compile. But look, what is very wrong in that thing? Let's create that maybe let's make it 4 like here, so it will be easier for us to understand it. And now it's of course cool thing, but we can do something like that, for example. That's very wrong thing. Why? Because when we create something like that, we have something like that here, and as you can see, we don't have anything after that place, right? We don't know exactly what is after that place. There might be other things stored in memory after and before. So right now we are trying to assign a value to something what is here. We don't know what is it. We are trying to do it, so probably we've just destroyed something. We just assigned to something very important a value like that. So that's really bad thing. Okay, so we can't do something like that because we could destroy our program. We could assign to other program something. So remember that we have to count from 0, 0, 1, 2, 3, 4. That thing, it doesn't exist. Well, we can't do it because it exists, memory exists there, but we can't, we shouldn't, we mustn't do something like that. Okay? Now let's see how to get that values from there. So for example, array, and let's do something like 0 equals, for example, that way. 0, 1, 2, and 3. 0, 1, 2, and 3. That are all 4 elements, right? That array, size of the array, so number of elements is 4. Let's build it, and as you can see, now we can see the values from that guys, because we use the index here. That thing is called index. Now let's try to maybe see what address have that elements. How to get address of element in the array. We are using also ampersand here, but let's do it that way. Address, and this time we are doing this that way. Array, and of course we have to add the index. So let's copy that 1, 2, 3, 1, 2, 3. And now we can see the address of all the guys here. That thing here is called hexadecimal. It means that we have 16 numbers in that notation. In our notation, we have 10 numbers. In notation, in binary notation that I talked about in the lesson about the bitwise operators, we have two numbers to use, right? 2 digits only. Here we have 16. Well, we can't have 16 numbers because we have only 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we only know that, guys, right? So if we want to have notation that have 16 numbers, we are using A, which is 10, right? B, which is 11, C, which is 12, D, which is 13, E, which is 14, and F, which is 15. And now we have totally 16 numbers here. I told you how to change notations from example, binary to the decimal notation. From the hexadecimal to the decimal notation, so to our notation, it looks the same. So for example, let's change 1 to A. And so I should just 1 multiplied by something plus 2 multiplied by something plus 3 plus A multiplied by something. And now we are in what notation? We are in 16 notation, in the hexadecimal notation, right? So we will do something like 16 raised to multiplied by 16 raised to A multiplied by 16 raised to, and now the position 0, 1, and 2. So 0, 1, and of course 2. And now what? We have 16 to raised to the power of 2, which is 256, plus 32 plus A multiplied by 1. A is 10, so plus 10, right? And we have what? 298. If you don't understand it, please go back to the bitwise operator lesson. And now, when I bid it, you'll notice what? That at the end, that things are moved 4 bytes. 0 at the end, now 4, now 8, so 8 minus 4 is 0, right? C, which is 12, 12 minus 8 is 4. So we are moving 4 bytes by 4 bytes. And that's like I told you here. So they are next to each other. You might be like, hey, why I'm focusing on things like that they are next to each other? Really, believe me, it will be very, very useful thing. Because we'll talk about pointers soon, and you will be like, wow, okay. I'd like to also add that the address of first element in array, so that guy here, can be also achieved that way. So the name of array is address of that guy here. Let's check it out. Let's see if it's true. Maybe I'm lying. As you can see, the address is equal to the address, so everything is fine here. So if I do something like that, if address of array 0 equals, that's true. That thing should be, of course, executed. Let's check it out. As you can see, that's true. I am not lying. Okay, so that's all about the arrays. And now, as you can see, for example, I told you I want to have 500 of elements, integer x 500, and instantly I have 500 of elements, and they are next to each other, right? So that's really cool. And now I can change, for example, it to 300. I can change it to 1000. So cool. But please remember that this number here must be here before compilation. we can't have, for example, that way, C in A, and for example that. We can't get the size of array when after we run the program. It has to be here before running program. So it could be something like that, constant, which means that this variable will not change for sure. And yes, that way I can do it, but I can't take it from the user and say, hello, I want, for example, 500 elements. We can't do it. We have to use dynamic operations to do that. We'll talk about them later, but right now we can't do it because we have to know how many of that guys here, you see, we will have next to each other before compilation, so our compilator will be able to do something like that, because he won't be able to do something like that after running program if we don't use the special operators to do it. So with that guys here, if that construction, we can only say, hey, I want 100 elements, and that's okay. We can't change it after running that program. Okay, that's all in this lesson. Thank you very much.